Hi everyone! In today's video, we're going to be going over the force of tension and some practice problems with tension. So tension is the internal force that occurs in a rope or cable, and it's due to the resistance of that rope being pulled apart due to a force. So for example, if I had this rope holding a mass, this mass is in equilibrium and it's not moving because of the force of tension, which we label as T. Tension can also occur if a person is pulling on that rope or cable. So for example, if this was a wagon and someone was pulling the handle, if the handle was a rope, and the rope gets taut, there is a tension force which causes that wagon to move. So tension can happen in simple scenarios such as pulling a wagon using a rope that has tension. Or in our next video when we go over pulleys, if we had two masses hanging, each one experiences a tension force against its weight. Okay, so now we're going to go over some example problems using the idea of tension now. And in our last videos, we described how to draw free body diagrams and how to solve these questions using force net equations. So if you don't know how to do that yet, I would recommend watching the past videos before going into this one. Okay, so this one's pretty easy. A 12-kilogram box is lifted with a rope such that the acceleration of the box is 3.5 meters per second squared. What is the tension in the rope? So first off, let's start with a free body diagram. We have a box and the weight is mg, which is equal to 12 times 9.8, or I'm going to use acceleration as 10, so 120 newtons. And there is some tension pulling upwards, and we don't know what that tension is. However, we do know that our F net equation, which is T minus mg, is equal to ma, and we have acceleration. So isolating T is equal to mass times acceleration plus mass times the acceleration of gravity. So putting these all in, we have 120 newtons plus 12 kilograms times 3.5 gives us a tension of 162 newtons. Okay, so this problem is a little bit more difficult. A 20-kilogram box is suspended in the air by two ropes. Rope 1 is at an angle of 30 degrees with the horizontal, while rope 2 is at an angle of 60 degrees with the horizontal. What is the tension in each rope? Okay, so this has a lot of information. What we want to do first is draw a picture or diagram of what's going on. And we know that there's a box suspended in the air, and there's two ropes holding it up. I'm not drawing the angles exact. One of them is at 30 degrees with the horizontal, and the other is at 60 degrees. Okay, what we have to do now is take a look at the forces acting on this box. First of all, a side note is that this box is at what we call a state of equilibrium, where it's not accelerating or moving, it's suspended in the air. So we know that there's a force of gravity acting downwards upon it. There is a tension force in this rope, which I'm going to call tension 1, because rope 1 is at the 30-degree angle. And rope 2, I'm going to call tension 2. So in this free body diagram, we have forces acting in both the x direction and the y direction. So this indicates that we have to find F net equations in x and y. So what I'm going to do is draw a small coordinate system right here so that I can draw these out more accurately. So this is where our box is. There is mg here, tension 1, and tension 2. Okay, let's start off with our F net X. So we know that there's two forces of the tension that have X components. And because the box isn't accelerating horizontally, we know that these X components have to cancel out. So we write our F net equation for X as tension 1 times the cosine of 30, because that's the X component, minus tension 2 times the cosine of 60, because that is the X component, equals to 0, because our F net is 0. So now that we have our F net X, let's write out our F net Y. F net Y is equal to T1 sine of 30, because that is the Y component of tension 1, plus tension 2 times sine of 60, because that is the Y component of tension 2, minus mg. And this is also equal to 0 because our box isn't flying upwards or downwards. So for both of these equations, I'm taking up as positive and right as positive. So just keep that in mind. So it looks like we have two variables here that we're trying to solve, and we have two equations. So we need to use substitution in order to solve for one of the tensions, because we have two variables in each equation. So I'm going to use F net X to say that tension 1 is equal to tension 2 cosine of 60 divided by the cosine of 30. Okay, so now that we have tension 1 in terms of tension 2, I'm going to plug this new equation into our F net Y equation to solve for tension 2. So replacing tension 1, we have tension 2 cosine 60 times sine of 30 divided by cosine of 30 plus tension 2 sine of 60, and I'm going to move over this mg, is equal to mg. Okay, so here we can simplify the sine 30 over cosine 30 and rewrite this as tension 2 cosine 60 tangent 30 plus T2 sine 60 is equal to mg. Okay, so now we have to figure out a way to isolate T2. And since we have T2 in both parts of this green equation, we can factor it out from the left side. So if we factor out T2, we have T2 times cosine 60 tangent 30 plus sine 60 is equal to mg. And now in order to isolate this, we have to do T2 equals to mg divided by that big trig thing, which is cosine 60 tangent 30 plus sine 60. So let's plug this into our calculator. We know that I'm going to take g as 10 meters per second squared, which you can also use 9.8, but because 10 is easier, that's what I'm going to use. So we know that mg is 200, and we have to divide it by cosine 60 times tangent 30 plus sine of 60. And remember that your calculator should be in degrees. This gives us a tension 2 of 173.2 newtons. Okay, now that we have tension 2, we can easily find tension 1 using this equation. We have tension 1 in terms of tension 2. So tension 1 is equal to 173.2 newtons times cosine of 60 divided by the cosine of 30. So let's plug this into our calculator. 173.2 times cosine of 60 and then divided by the cosine of 30. This gives me a tension of 99.9 newtons, which I'm going to round up to 100 newtons. So that is how we found the tension in rope 1 and rope 2 given the angle and the mass of the box. So this problem is also asking you to solve for two unknowns, but this time one of the unknowns is an angle. A 12-kilogram box is suspended in the air by two ropes. Rope 1 is horizontally tied to a wall, and rope 2 has a tension of 130 newtons, pulling at some angle above the horizontal. What is the angle of rope 2 and the tension in rope 1? Okay, so I took the time to draw a picture for this word problem because it is a little bit harder to visualize. So all we have to do is draw a free body diagram. So first we know that there is the gravitational force mg acting on the block, and once again I'm going to use g as 10 meters per second squared because it's just easier to calculate with. And this gives us an mg of 120 newtons. We know that there is a tension force acting at 130 newtons at this unknown angle. And because if we break up this 130 newton tension into x and y, we know that the x component acts to the right. That means that the tension in rope 1 has to be to the left. So there is an unknown tension pulling to the left. Okay, so now that we have our free body diagram, let's write out our F-net equations. Once again, because the box is suspended, both F-net x and F-net y have to equal to 0 because our box isn't flying up and down or left and right. It's suspended in the air. So F-net x, we're taking right as positive and left as negative. So we have 130 cosine of theta, which is the x component of rope 2, minus tension 1, and this is equal to 0. F net y is simply 130 sine theta, which is the y component, which has to equal to mg because they have to cancel out, which is equal to 120 newtons. So because we simply have 130 sine theta equals 120, we can solve for the theta of rope 2. So sine theta is equal to 120 divided by 130. And isolating theta means taking the sine inverse of both sides. So theta is equal to sine inverse of 120 divided by 130. So let's plug this into our calculator. Sine inverse of 120 divided by 130 gives us an angle of 67.38 degrees above the horizontal. Okay, now that we have theta, it's really easy to solve for tension 1. Using our F net x equation, we can see that 130 cosine of theta is equal to tension 1. So all we have to do is plug in the theta. So tension 1 is equal to 130 cosine of 67.38. So let's plug this into our calculator. 130 times cosine of 67.38. That gives us a tension 1 of almost exactly 50 newtons. So that is how we solved this particular problem. Thank you so much for watching this video. I hoped it helped. And if you're looking for practice problems regarding anything with forces, I have a link in one of my previous videos for Dynamics Lesson 1 and 2 in the description. In our next video, we will be going over Atwood machines and pulleys, where we will be using this idea of tension a little bit more intricately and it's a little bit more difficult than this. So I'll see you in the next video. Thank you.